Hey everyone, in this video I will show you all a very simple example about the implementation of dependency injection in your C# application. Before I begin, I would like to request you all that if at any point in this video you feel that you like the contents or you think the video helped you to improve your understanding of this topic, then please take a moment to subscribe to this channel if you haven't already done so. It will be a great help and encouragement for me to keep creating new videos on a regular basis. I want to keep this video short, so I will focus more on the coding side and less on the theoretical part, as you can easily do a simple Google search to get to know a variety of definitions. But still, I'm going to explain in a few lines what dependency injection really is and why it is used so extensively in all the major programming languages. Dependency injection is simply a design pattern where we supply the dependency for an object which the object uses, thereby decoupling the implementation code from the calling code. This design pattern also allows us to achieve inversion of control, which simply means that the caller has the control over the code which will execute instead of the other way around. Alright, so let's quickly move on to the code example. So over here I have created a console application in Visual Studio, and for this example I'm just going to show you a very simple scenario in which for any exception raised in the course of the application's execution, the error will be logged somewhere, and I'm going to show you how the design pattern of dependency injection can really help in implementing this scenario. So first I'm just going to write a try catch block where we will be able to mimic the situation when any exception has been raised. So in the catch block we will be able to get the exceptions, and in the try block I'm simply going to throw a new exception. Let's say that any divide by 0 exception has been raised, and we will be able to catch it over here. Now to log the error somewhere, we can either write the code directly in the catch block, but this will not be very efficient because if there are different catch blocks in multiple places in the application code, then we will have to replicate the code everywhere. So for this purpose we can simply create a class file, and I'm just going to call this class file as text logger because it is going to log the messages in a text file. And in this text logger class I'm simply going to create a single method, and let's call it log. We also need to supply an argument for the message which we are going to log, and inside this log, let's say this console.writeLine is actually going to write the message to a text file for the purpose of this video, and log to a text file, and then we can provide the message over here. So this text logger class will log the messages to a text file. Now we can use this class over here by creating an object instance out of it. So let's do that. Just a new text logger, and then we can simply call this loggers log method, and we can provide the message of the exception as an argument over here. Now it would be better if we not create the object in the catch block itself, and we create the class instance somewhere from where it can be shared with all the modules and with all the layers, so that every catch block will not have to create the instance of this logger object over and over again. Now this logger is to log the messages in a text file. What if the user decide, or what if we decide that we need to log the messages to a database? For that purpose we can create another class, and we can call it database logger, and I'm just going to simply change this message so that we can see if the correct object is being used or not. Now to use the database logger instead of this text logger, we need to make the actual code change, but it will also mean that whenever we need to make such a change, then the application will again need to be built, and it again needs to be redeployed to the staging and production servers. the code base will need to be tested again for the most part, and there could be several different steps involved related to the project management, and I don't know, business analysts will have to do some different stuff. They will have to update specifications. The PMs will need to developers to do this stuff. I mean, there are a lot of different steps involved for doing such a simple thing. So the solution to this problem is to create a mechanism in which we don't actually need to make the change in the code, and we can simply make a change in any configuration file, and the code will be able to read which logger it needs to use, and it will simply work as it will be working without any code changes required. So for that purpose we need two more entities, and the first one is going to be an interface for the actual logger class, and I'm going to name it iLogger. Now this interface is going to have a single method which will be in the log, and this interface will act as a binding contract for these both classes, text logger and database logger. And apart from this interface, we will also need another class which will be the log manager class, and inside this log manager class I'm just going to create a private variable of type iLogger, and in the constructor what I will do is I'm simply going to supply an argument of this iLogger type. So whenever the object of this log manager will be created, we need to provide the type of logger which this log manager will use, and in the constructor we can simply set the reference of the logger which is being supplied to our private variable, and then we can create another method over here. You know what, let's use the same one with the same signatures, log and then a string message, and inside this method we can simply call this loggers log method. Now instead of using the actual implementation class, we can use this log manager class. So we will not be dealing directly with the concrete logging classes themselves. We will be dealing with a kind of a facade or a kind of a middleware to access the specific kind of logger which we will need to use. Now we also need to provide the argument for the logger which we need to use. For now I'm just going to provide this database logger over here. Now instead of using the logging class, we can use the log manager class to log the message, but this is still not a dynamic code. If we need to switch the type of logger, then we will need to switch the type over here. Now the solution to this problem is to read the type of logger from a configuration file and then create the logging or iLogger type of object based on that information. So first I'm just going to create a variable or a field over here for iLogger, and then let's say that we will read the type of logger from a configuration file, and for that I'm just going to create a string variable. So let's say that initially the type is set to text. Now we can, I mean, this code is pretty simple. At the actual implementation, the actual production level code will be much complicated than this, which will cover more scenarios. So if the case is database, then we need to create a database kind of logger. For any other value, we can simply use a text logger. because we need to fall back to a default logger if none of the if the configuration files value is not matching any of the available logger classes that we have created. So now what we need to do is we just need to create the actual logging classes which we need to use, and over here we need database logger. For the default one we are using the text logger, and I'm going to remove this line, and then whatever logger class instance will be created, it will be passed as an argument over here. So basically this is called as a constructor injection because we are injecting the dependency in the constructor of the object. So yep, that's it. Now it's time to run our code and see if it's working or not. So right now the default logger type is set to text, so the message which will be displayed should be this one, log to a text file. Actually I need to, I think, to be able to see the results. Alright, so you can see the exception has been raised and the message which we are seeing is logged to a text file because we are using this text type of logger. Now if I will change the type of this, let's suppose that we are doing this in the config file. So in that case the message which is being printed is logged to a database. So by doing this we are actually decoupling the actual logger class with the log manager which we are using to log the message. And if in the future we need to add more logger classes, then we can simply create more classes. That will be the need for the implementation of an entire different logging class. But if we already have all the logging class available in our code base, then all we need to do is change the setting in the config file about the logger type which we need to use, and then the code will take care of all the things itself. So yep, I hope that you have understood the example because it doesn't get any simpler than this. And still, if you have any questions or you have any suggestions to make, then please feel free to use the comment section, and please like the video if you think it's good. And yep, that's it for this video guys, and I will see you in the next one. Have a good day.